Welcome back. And for the last part of this video, we're going to talk about the additional topics that were covered in the conservation block of instruction in your Physics 205 or 255 class. We have really two other topics that we want to make sure we highlight as we study and prepare for WPR number 2. The first one is impulse. Impulse is also a vector. And our equations from our PRC, the symbol for impulse is J, and our equations for our PRC is that impulse is equal to our change in momentum, or that impulse is equal to our average force over a period of time. Those are the two equations that we have from our PRC. Now, if you're in my class, I gave you a third equation that I want to make sure you remember and use when solving impulse problems. And that is really what the definition of impulse is, which impulse is defined as the integral of a force over time. So when I integrate my force over time, that gives me my impulse. And how do I do that? Well, typically, if I'm going to give you a plot that shows some force over time, so this will be measured in newtons, and I get some force as it changes over time. My impulse is simply, when I integrate that gives me the area underneath the curve. That area is going to be, the magnitude of that area will be my impulse. All right. We've done a couple problems like this in class. So if I wanted to look at some additional examples of where this has been done, you can look at, from our text, you can look at problem 9-32. 9-32 would be a good one. And then for those that are in my class, Expert TA from lesson 19. We did a couple from lesson 19. We did problem 11, which I'd make sure I understand, and problem 5. All right, perfect. Now, our second topic that we covered in this block of instruction that we need to make sure, our second additional topic is center of mass. And this is the last topic that we're going to cover as we prepare for WPR number 2. And remember that when we're finding center of mass, what we are finding is a point. We're finding a point on an object, and that point is going to be defined differently depending upon where we define our origin. So it's important when you're calculating the center of mass that you identify what you are using for your origin. Now, on our PRC, we have two equations. We have two equations for our center of mass. And the first one is that the center of mass is equal to 1 divided by the total mass of my system multiplied by the summation of every piece of my, every particle in my system. So this formula works when I've got several point masses or separate objects that I want to add together in order to determine where the center of mass of that system is. All right? The second equation that we've got in order to calculate center of mass is that the location of the center of mass relative to some origin is equal to 1 divided by the total mass of my system or object multiplied by the integral of r, and it's weighted by a differential mass. So I'm integrating over mass and where that mass is located. So I'm weighting the mass based upon its position in the system. Now, when you do this, integrating over mass is not easy. We don't typically do it. We integrate over dimensions, over volumes. And so if you do this, don't forget that we need to substitute using density. How that density will be how we transition from integrating over mass to integrating over volume. So if it's one-dimensional, then I'm going to use a linear mass density and say that lambda is going to be equal to dm over dr. If it is two dimensions, then I need to use that sigma, which is my two-dimensional density. My area density will be equal to dm over dA. And if it's three dimensions, I use that rho, which is my volume density, is equal to dm over dV. All right. We've done several problems like both of these. Well, we've done a couple problems for both of these. For the separate points that we add together in order to identify our center of mass, you've got from your text, problem 9-63 is one I would make sure I look at. You've also got 9-76, which is one we didn't do in class, but I would take a look at. You can look that up in your text, problem 9-76. And then also from your text, inside the section where you read, you can look at example number 9-16. So I'd look at example 9-16 for my text. And all three of those will help you get after this strategy for calculating our center of mass. And for the integral, we have, from the required problems, required problem 9-1 is one that I would look at and make sure I understand. All right, well, if you look at these videos, hopefully they